Hi, I'm Professor Kadiravan. Welcome to my channel. Today, I'm going to discuss about Shannon Fano coding. Shannon Fano coding was named after Claudie Elwood Shannon and Robert Fano. It is a technique which is used for constructing a prefix code based on a set of symbols and their probabilities. First, let's see about its algorithm. Step 1. For a given list of symbols, develop a corresponding list of probabilities in decreasing order. Step 2. Partition the list of symbols into two sets that are as close to equiprobable as possible and assign 0 to the upper set and 1 to the lower set. Step 3. Continue this process, each time partitioning the sets with as nearly equal probabilities as possible until further partitioning is not possible. For clear understanding, let us see an example. Suppose you are provided with a problem stating that 5 symbols of the alphabet of a discrete memoryless source and their probabilities are given as S is equal to S0, S1, S2, S3 and S4, whereas P of S is equal to 0.4, 0.1, 0.2, 0.2 and zero point 0.1. Code the symbols using Shannon Fano coding. The solution for this problem can be obtained by following the Shannon Fano algorithm. This table here is what given in the question. According to the algorithm, step 1 is listing the source symbols in the order of decreasing probability. As you can see, the order is completely changed now. I have placed the symbols according to the probabilities. Step 2 is about partitioning the probabilities into two sets by addition. From the given values, there are two options in splitting. The first option is adding 0.4 and 0.2, so we get 0.6. Likewise, adding the result of the values, we get 0.4. As per the rule, the added values must be equal or somewhat equal to each other. In our case, zero point 0.6 and zero point 0.4 are somewhat equal. The second option is splitting zero point 0.4 alone and adding the remaining values together, which will be zero point 0.6. So therefore, the output will be same however you partition the probabilities. Here, I will consider the first option. After partition, assign value 0 to the upper set values and 1 to the lower set values and name that column as stage 1. Now perform partition again to upper and lower sets individually. As there are only two values in upper set, assign 0 to the first value and 1 to the second value and name this column as stage 2. Moving on to the lower set, there are three values which are 0.2, 0.1 and 0.1. Adding 0.1 and 0.1 we get 0.2. So therefore 0.2 and 0.2 are equal. Therefore assign 0 to zero point 0.2 and 1 to remaining two values. In stage 3, split 0.1 and 0.1, assigning 0 and 1. Now the partitioning ends here as all the probabilities are partitioned equally. Let's keep this table aside and create a new table for finding the code word and its length. Place the symbols and probabilities in the same order as in previous table and include two new columns, namely code word and length. For S0, that is 0.4, in stage 1 it is 0 and in stage 2 it is 0, so the code word is 00. For S2, which is 0.2, in stage 1 it is 0 and 1 in stage 2, so the code word is 01. Likewise for S3, stage 1 is 1, stage 2 is 0, so the code word is 10. For S1, code word is 110 and for S4, code word is 111. Moving to the length column, count the digits in code word column and enter its numerical values. For S0, there are 2 digits, so the length is 2. For S2 also there are 2 digits, so here also 2. S3's length is also 2. In S1 and S4, there are 3 digits in code word, so the length is 3. Next step is finding entropy, which goes by the formula H of S, which is equal to the summation of I is equal to 0 to n into P suffix I log base 2 of 1 divided by P suffix I, where n is the number of symbols. In our case, it is 4. Expanding the equation, we get P naught into log base 2 of 1 by P naught plus P1 into log base 2 of 1 by P1 plus P2 into log base 2 of 1 by P2 plus P3 into log base 2 of 1 by P3 plus P4 into log base 2 of 1 by P4. Here it is log base 2. In scientific calculator, it is programmed to provide output for log base 10. So let's make a small change in our equation. So entropy H of S is equal to P naught into log of 1 by P naught divided by log of 2 plus P1 into log of 1 by P1 divided by log of 2 plus P2 into log of 1 by P2 divided by log of 2 plus P3 into log of 1 by P3 divided by log of 2 plus P4 into log of 1 by P4 divided by log of 2. Now let us substitute the probabilities in our equation. So after substitution, these are the values for entropy. So the calculated values will be 0.5287 plus 0.4643 plus 0.4643 plus 0.3321 plus 0.3321. The total is 2.12 and the unit will be bits per symbol. Next step is to find the minimum code word length. It is represented as L dash and is given by the formula summation of I is equal to 0 to n into P suffix I into L suffix I, where P suffix I is the probabilities and L suffix I is the code word length. Expanding the equation with n is equal to 4, we get P0 into L0 plus P1 into L1 plus P2 into L2 plus P3 into L3 plus P4 into L4. Now substitute the values from our table. 0.4 into 2 plus 0.2 into 2 plus 0.2 into 2 plus 0.1 into 3 plus 0.1 into 3. The total calculated value is 2.2. Here the unit is bits per symbol. Next step is to find its efficiency. This is the symbol of efficiency and it is defined as the ratio of entropy to minimum code word length. That is, efficiency is equal to H of S divided by L dash. Substituting the values of H of S and L dash, the efficiency will be 0.96. And converting this into percentage, we will be getting as 96 percentage. Last step is to find its redundancy, which is given by the formula 1 minus efficiency. Here the efficiency is 0.96, so 1 minus 0.96 is equal to 0.04, which can be considered as 0. Always remember, when redundancy is 0, then the method you have done is correct, or else recheck the previous steps as you might have done some mistake. Thank you for watching this video. Hope you would have understood the concept. Subscribe my channel for more such videos.